Hello, my name is Isabel Wang and my partner is Shivani Pulley, who is in Dr. Zacharias' 4th period class. Our project is on the removal of pigeons from rooftops and balconies on apartment buildings. Why pigeons? Pigeons are nuisances for any property from buildings to outdoor spaces. They tend to roost in hard-to-reach places. They also leave droppings that can carry disease and are highly caustic, meaning they can wear down building materials and threaten structural integrity. Having adapted to life around humans, they are hard to permanently scare away and keep away. Current products on the market, ranging from home remedies to mothballs to pigeon repellents using sound, can repel pigeons safely and humanely, but are limited in their effectiveness. Our solution is to create a model that detects and tracks pigeons on apartment building rooftops and balconies. We plan to place multiple machine vision cameras or webcams at different angles in the location. The model takes the footage and communicates with a robot tasked with scaring the pigeons away using mechanisms such as sudden movement towards the pigeons and playing sounds of their predators. We originally intended to use the You Only Look Once real-time object detection system, or YOLO, and the Deep Simple real-time tracker, also known as Deep Sort. The YOLO model applies a single neural network to the entire image, divides the image into regions, and predicts bounding boxes, which are weighted by probabilities for each region. This model has advantages over classifier-based systems because it takes into account the global context of the image at runtime. Deep Sort utilizes Kalman filters and the Hungarian algorithm. Kalman filters use available detections and previous predictions to arrive at a best guess for the current state of the image. They process noise in an image with moving objects. The Hungarian algorithm is very effective for problems involving assignment and association, like ours. To train and test our model, we compiled a number of datasets containing images and videos of common objects, humans, animals, and birds, specifically pigeons, among other things, which we originally intended to use. These databases include the Common Objects in Context, or COCO dataset, the CFAR dataset, the YouTube AM dataset for videos, and the Macaulay library, which has lots of different images of bird species. My winter goal statement was to have a fully trained YOLO version 4 model, also known as the You Only Look Once real-time object detection system, that can detect pigeons in images, and to also have decided on or be ready to purchase a camera we can use to get the model working on live camera footage. The model will output photos with bounding boxes drawn around the pigeons, or at least the ones that are obvious to the human eye in the photo. At first, I plan to fetch the images from several databases, like mentioned earlier. However, images of pigeons were either few in number or difficult to access or annotate, so I decided to build my own data set from Google Images and annotate them using a software called Label Image. I then successfully uploaded the annotated dataset after several tries due to repeated images in the dataset or annotations not showing up in an image. I was initially training the model on my computer using the terminal, but I decided to switch over to a Google Colab notebook in order to take advantage of the GPU and the cloud that Colab uses. I uploaded the annotated to RoboFlow, like I mentioned earlier, because it allows Colab to access the dataset directly. I also had to run the training algorithm several times before it worked because I was getting either too many labels or none at all. Some of these were attributed to having annotations not showing up in an image. These are my results. These images were pulled from the testing set of my data set. As you can see, the model recognizes almost all of the pigeons in the leftmost image and draws pretty accurate bounding boxes around the pigeons in the images on the right. So I would say it successfully accomplishes my winter goal. We decided to use the Logitech C920 webcam, which has features such as autofocusing, a 78-degree field of view in 1080 pixels at 30 frames per second. These specifications are both sufficient and useful for our application. Finally, my spring goal is to have our model be able to track pigeons or draw bounding boxes around them as they move in real time using live webcam footage. Thank you for listening to my presentation.